My name is Christoph, as you already heard, and I'm a freelancer. I'm from Berlin, and I build multimedia applications, as you all also already heard. And yeah, some of my clients are in this room, so if you are interested in an honest opinion on how it is to work with me, then you should probably better ask them instead of me. I'm going to talk about synchronizing audio on the web, and I thought I should start with a picture like this, just to make sure the locals like me. And it's, as far as I know, this is the horse cart. Not sure if it's true, so please, don't take it too serious. And it's part of the strange group, which is there to protect the royals. And as you can see from the picture, they have a diversity problem. That's the one thing that you can see clearly. And the other thing is that they care about synchronization. And they try to be in sync as good as possible. And you can see it on the other picture, that they even play music while doing so. So they actually have the same problems as we do, but they...
But they're not on the web.
No, they're not on the web, that's right. And yeah, but I derived the rule from that, from these two pictures, and that is that synchronization is basically just when two or more things happening at the same time, but they happen on purpose. Like that's very important, because if two or more things happen at the same time and they weren't meant to happen at the same time, that's probably what you would call an accident. And if you meant two things to happen at the same time, then it's synchronization. And I have one more picture, which is this one. And if you can see it in the back, it's very small, but it's 6 military jets flying in formation. And they show another interesting property of synchronization, which is that being off by a large amount is probably fine, but being off by a few meters is terrible. Like if you are one of these pilots and the pilot next to you is off by 10 meters or 50 meters, don't know how far they are from each other, but if they are off, then you probably don't like it. And this is also true for synchronization in general. Like it's, if you try to synchronize something and it fails, people will most likely notice. It's, in many cases, it's better to not even try if you can't, because then no one will expect it to be in sync. But if you try and you fail, then it mostly sounds, noticeable. And for audio and media in general, synchronization, as you probably all know, means just aligning two clocks or two timelines. I would argue that this is basically the same task. I don't know what the difference is between the two. We always have samples or frames on a time scale, and if we don't play them in the exact order as they were meant to be played and at the exact time which they are meant to be played, then it's a different media. It's not the same anymore. So that's basically all we have to take care of when we do synchronization on audio. And browser APIs is the other APIs which we are going to talk about, and they are a mess, as I wrote down here. And there are a lot of them, and they all do different things. They all somehow deal with audio, but they all do it a bit differently. And the reason for that is that browser APIs get created by various people in various points in time, and they all have different interests and different ideas. And once there is an API in the browser, it cannot really be removed anymore. Like if 10, 100, 1,000 or millions of people use it every day, then you cannot just remove it anymore. And that's why the browser is basically an append-only database, like if you want to use a modern password. And everything which is in there gets only removed if there's a security issue, like with Spectral Meltdown, then that will remove some APIs. But in general, it will always add new APIs and never remove the old ones. And I tried to I gave a talk which tried to summarize all the APIs at the ADC in 2019. So if you are interested in that, you can rewatch that one. And yeah, I also wanted to mention that all these audio APIs, they have obviously a notion of time because they need to play media. But some of them tell you what their notion is, like the WebRTC API, but the audio element doesn't really do it. Like it's doing all that magically internally, and it gives you some hints with its current time property, but yeah, it's not so obvious what it's actually doing. But yeah, this sounds very negative. I realized that when I rehearsed my talk, but it's actually not meant in that way. I really enjoy my work, and Yeah, the reason why I left the slide in there is because it's a good excuse for an unstructured talk. Because if I say that the APIs are a mess, the talk is a mess as well. So that's the reason why. And there's an effort to mitigate the problem. It's called the Extensible Web Manifesto, and it was published in 2013, so almost 10 years old now. And the idea behind that is that browser vendors should not, or the W3C should not specify new high-level APIs. They should better expose low-level APIs first, and then it's up to web developers to come up with high-level APIs, which everyone likes and everyone enjoys using. And once there's consensus reached, then that might get standardized as well. But if not, yeah, everyone can use whatever they want. But of course, there are already high-level APIs available, which are out there. And as I said, nothing can be removed. So the idea is that for those, there should be new low-level APIs which can explain those APIs. Like, explain is the term that's used in the manifesto, but what I would call it is like re-implementing. Like, there should be new low-level APIs to re-implement the higher-level APIs that we already have. Web components is, for example, one of those examples. But for audio, it's the media element, and that is around, I don't know, forever. Michel knows when it was created. I don't, but it's a long time ago. And 2009 is what Michel just said. And it can be re-implemented in the browser today. Like, there's a demo created by Matthias Bühlens. It's called Baby Video. So he was mainly targeting the video element, which is, I always say media element and audio element and video element as if they would be the same thing, and they basically are. Like, the media element is the theoretical thing, which is the definition of both, and then you have the audio and the video element, which can play audio or video, but they are both a media element. So that's why I use the terms interchangeably. And what Matthias did is he used web codecs, off-screen canvas, and I'm not sure if he is using the audio worklet because he was targeting video as a primarily use case, but that could be used as well, and then you can re-implement at least parts of the media element, like the most important things for playback. All right, now let's talk about how you would synchronize something. The media element is the most basic thing in the browser, which most people know, and it's has a declarative API that you can see on the top. It's a DOM node called audio, and you just give it a source file, and then you can call play on it. And what I did here, I just used query selector all to get all the audio elements, and then I loop through them and just call play. And that sounds as if it should work, or looks as if it should work, but it doesn't sound as if it should work. Like, you will clearly hear that this is not going to work, and this is because the play function is not really deterministic. Like, it plays if it can, and if it can't, it doesn't, or it waits a bit and then plays. And that's because the media element does a lot of magic under the hood, and it's really hard to know what it's actually doing. Like, it's streaming the audio if possible. It doesn't stream if it can't. It's also possible to do that on your own. Like, you could use media source extensions to feed the buffer yourself, but still you don't know what it's currently up to. Like, if you call play, if it's busy with something else, if it has decoded everything or not. And it's just a quick and easy way to play something at the same time, but it's not really synchronized. Like, it's a nice try, but most of the times it doesn't work. There was something called media controller, and that was a nice API. Like, it has a declarative part, which we see here, but it also had an imperative one. And all it does is you assign media elements to a group, and then that group is tied together. Like, when you call play on one of those elements, the other one plays as well. If you pause it, then the other one pauses too. And that's a nice idea, but it was apparently removed from the spec in 2016. There was an implementation in Chrome too, but yeah, the Chrome team decided to drop it. And with only one implementation left, which is still available in Safari today, it was also removed from the spec. And I find this very interesting because it's the only one example that I know where Apple is not blocking a new spec on the web. So this is very interesting in that regard, but apparently it's also not the only example of a poorly implemented API in Safari, because it has a lot of latency. Like if you call play, it's up to 1 second until it finally starts playing. And I guess it's just internally buffering all the audio elements to be sure it can play them in sync. And so if you don't care about the timing of the initial start and you only target Safari, then this is a viable solution, but I guess no one does that. So yeah, apparently cannot be done. There's another thing also called also used for timing. It's called the timing object. It has basically the same idea as the media controller, just assign something to all of the audio elements and then they are tied together. But the timing object is generic. It's not really meant for, well, it's of course meant for media, but you can use it for whatever you want. And that's why the API is a bit different. You would create a timing object first, and then you would loop through all the elements again, and first only assign the timing object to those elements, and then later on you can use the timing object to control those elements by changing the vector. Like the timing object internally works with a vector, and that's why there's this strange update velocity 1, but it basically just says play. That's all it does. And here you need to use the library because the timing object is a draft and it's not yet a spec. It's a spec, but it's not yet a standard. So it's only a draft by now and it's not in any browser. But it's also one of those APIs which were defined a few years ago. It wasn't implemented in any browser, but now with the new lower level APIs, it can almost be fully implemented in JavaScript. And that's what I did with the timing source library. And finally, this is how you would do synchronized audio playback with the WebRTC API. This snippet assumes that you already have all the buffers in place. That's because it's a requirement for the WebRTC API. If you do use an audio buffer source node, you need to have the buffers available first. Like it doesn't do any streaming. That is bad, but it doesn't do any undeterministic loading, which is good. So that's the trade-off between the WebRTC API and the audio element. And here I just create an audio buffer source node for each of those buffers. I connect it to the destination, and then I call start. And this should work, but it doesn't work as well. Like start is a magic function. It, as I said, the WebRTC API is not that magic as the audio element, but it still has a few magic things, and the start function is one of those because it takes an optional argument of current time, which says when that audio buffer source node should start. And if that start time has already elapsed by the time the message arrives on the audio thread, it would just shift the buffer to whatever time it is currently at. And that will delay the playback, which is nice because you hear all the samples that you were meant to play. But it's also bad because you have no idea when this is happening. Like, there's no way to know if this is happening or not. And to mitigate that, I combined the timing object with the audio buffer source node. And because I'm not afraid of long names, I call this timed audio buffer source node. And if you want to use this, the NPM package is actually called timed audio buffer source node audio workload node because it's implemented with an audio workload node internally. And what this does is basically it has the same API as the audio buffer source node, but it's not controlled by start-stop method. It's controlled by a timing object, and the timing object dictates what's happening on the audio thread. Like if the message arrives too late and the audio thread cannot play all the samples, it will just play from the current offset, and that means you will probably skip a few seconds, a few samples if you are unlucky, but you can always be sure that it will follow the things that you scheduled and will not do any magic under the hood for you. So if you want to play something in sync, that's actually the way I would recommend doing it. And since WebRTC became a lot more popular in recent years for obvious reasons, I quickly wanted to mention that if you get a stream from WebRTC and they are bundled, like media and audio is usually bundled by default, but you can also bundle other streams, then they are kept in sync for you, like the browser or libWebRTC, to be more specific, is trying its best to keep the streams in sync up to a certain amount. Like if there's a large amount of packet loss, then it will give up eventually, but and you also don't know when this is going to happen. But in general, it's kept in sync. But you have to be careful if you do any processing with the audio, then you lose that advantage. Because, as I said before, the browser APIs are a big mess, and WebRTC is also its own kind of thing. It's hasn't really anything to do with the WebAudio API, and I guess in all browsers, it also has nothing to do with the WebAudio API on the code level. And that means once you get that stream in the WebAudio world, it basically left the WebRTC world, and then you are on your own to synchronize it again with the video, which is tricky. I just wanted to mention that. So okay, the things that I just I've just shown, that they are just for playing something in sync right now, like if you want to play something in response to a user action, for example. But sometimes we are lucky and we know ahead of time that we can special. Do you have a question? Or? Sorry. Later. Okay. All right. Yeah, sometimes we are lucky and we know ahead of time when we are going to play something. For example, if you rebuild the streaming of the audio element with the WebAudio API, and as I said before, you have to know all the buffers in advance before you can play them. But you can obviously just play what you already have with the buffer, but then you have to know when the first one was started to start the second one, because otherwise you will hear glitches. And for that, we can obviously schedule things. And just to mention it, you could do this with the media element, and I hope I made clear that it's a bad idea, but you could make it even worse by wrapping it in a set timeout code. I saw this in the wild, so I thought it's worth mentioning. And set timeout has also a lot of issues, like it's, well, it doesn't have issues. It wasn't designed for that. Maybe that's the right way of saying it. And the way it works, it says do something in 1,000 milliseconds or later. Like it doesn't say do something in 1,000 milliseconds. And that's because the browser can't guarantee it, because it's doing everything in a loop, and maybe it's currently busy doing something else when the time is over. But JavaScript always runs to completion, and that means the thing it's doing right now needs to finish, and then it's doing the callback. And that might be, if you're lucky, it might be in 1 second, but most likely it's later. And it could be way later if the browser is currently throttling the thread, which is also happening if you go to a different tab, or if you minimize the window or something else, then the browser might throttle these calls very aggressively. There are, again, ways to mitigate this. You could use a library like worker timers to run the timeout on the worker, because the worker doesn't get throttled. But again, it's still brittle, and it only works if you're really lucky. And the timing object is also has the same problem. Like it plays things perfectly in sync, or it can be used to play things perfectly in sync. The timing object itself, as I said, is generic and doesn't play anything, but you can use it to play things in sync, but it doesn't allow you to do any scheduling, and therefore you would still need to wrap it in that set timeout call, and yeah, you basically run into the same problems as I said before. But here the audio buffer source node is our friend. We can absolutely use it to schedule something in the future. Like if we schedule something 1 second ahead, I guess that's safe to assume that the message arrives on the audio thread in time, and the full buffer gets played as expected. And here, if you notice, I use +1 instead of +1000, because the WebAudio API is in seconds instead of milliseconds as everything else, because why not? And also worth noting is that I grabbed current time at the beginning, and then used current time throughout the loop, because current time is the value of current time that it was on the audio thread, the latest time the audio thread reported the value. And that might actually change while you are executing the code. So if you run the loop, the for loop, and you are very unlucky, it might happen that current time progresses in between if you access it live from the audio context, and then yeah, you are not in sync anymore as well. Okay, but these were all like scientific laboratory examples, because in real applications, you're not always that lucky that you can only use one of these APIs and then you can do what you want to do, what you think is best. You most likely have to work with what's already there. And if you need to combine, for example, the media element and the WebRTC API, you can use the method called getOutput_timestamp, which gives you a pair of values called context time and performance time. And the one is the time in relation to current time from the audio context. And the other one is the time in relation to performance, performance.now, like if you would call that on the main thread. And these two values are what these two properties would be at a specific point in time. So you can use those to map from one domain to the other. But this is subject to change, like it's changing over time, so you have to do this repeatedly if you want to synchronize something for a longer amount of time. And then there are two new HTTP headers which you can enable. They are called COEP and COOP. I explicitly don't want to say the full names because I forgot them. And they are actually mostly used, like if you Google for and re-enable shared array buffer, for example, you will find examples of enabling them because they tell the browser to only load safe third-party resources. And in return, since the browser knows, okay, I'm only allowed to load safe third-party resources, I can also enable shared array buffer again, because otherwise it would be insecure. And with that, it also enables high precision timers, because normally to mitigate this Spectre meltdown attacks, the timers in the browser are not really accurate anymore. Like I think Firefox is rounding to 4 milliseconds and Chrome is doing something differently. Like they all do a different thing, but in generally they all smooth the timers somehow. And if you enable shared array buffers, you also get the benefit that these timers will be high precision. So even though you don't use shared array buffers in your code anywhere, it's also worth thinking about enabling those two headers because they will make the timers more precise. And then a word of warning, like before I said WebRTC is trying to keep the streams in sync whenever it can. But WebRTC is also one of those APIs which expose a media stream. You also get one when you ask for the microphone, or when you can grab the audio from a media element and pipe it into a media stream. Whenever you do this, you're basically on your own, or you are at the browser's mercy because no one knows how long the media will stay in the media stream. It's not specified, and yeah, it doesn't tell you. It's just doing it, and there's nothing you can do about it. And it's also different from browser to browser. Like in Firefox, they just copy the values if possible, but in Chrome they definitely do not, because the WebRTC API and the other media APIs, they are very different things, and they cannot just copy them. So there's always, whenever there's a media stream, there's buffering involved, and the worst thing about it is you don't know how much. And if you have two or more output devices, like imagine you have a DJ-style application and you want to have two different audio output devices, then, as I said before, like for accurate scheduling, you would need the WebRTC API. But unfortunately, that is not possible yet because the WebRTC API always uses the default audio output device. That's going to change soon, but don't know how long soon is. But it's already planned to be implemented in Chrome, but yeah, don't know how long it will take. Like the future version of the WebRTC API will have an option to set the sync of an audio context, which would then allow you to run two different audio contexts going to two different devices at the same time. And again, you would then need to do get output timestamp calls on both of them and decide which one is the one which you use to drive the synchronization and then synchronize the other to it. And if you have two or more devices, like if you want to play the same audio on multiple devices, I would recommend using a timing provider for it. That's also part of the timing object spec. and the timing provider sits on top of a timing object and can synchronize it with other timing objects in other browsers or on other devices. And that allows you to synchronize time, and then you can use that time to use the same trick as before, use get output timestamp in relation to performance.now, and then do a couple of mapping operations to finally know at which point in time you have to schedule things. It's still tricky, but it's possible. And last but not least, I want to quickly talk about how to synchronize audio to an external source. And there's not much magic involved here, because there's basically only one thing that you need to watch out for. If you get an event from somewhere, I used the WebMIDI API as an example here, but could even be a mouse event, and you want to know, you want to do something in reaction to it, and it should be tight and accurate, then you need to use the timestamp on the event, because the main thread where you get these events is busy doing stuff, and it's doing that in a loop, and at the time the user clicks, or at the time the MIDI event comes in, it might currently be doing something, and once it's calling your callback, there has been a little delay. And that's unfortunate. There's nothing you can do about it unless the WebMIDI API becomes available in a worker, which I think is not going to happen anytime soon. But you can at least handle it. Like if you know the delay, you can do something with it, or you can adjust your play out accordingly. And then there's also Ableton Link, which you probably all know, but that is not possible yet to connect to Ableton Link directly in the browser, because it uses network messages which you can't send and you can't receive in the browser, so there's no way to participate in a link session in the browser yet, but you could definitely build a bridge like the timing provider, which I showed before. That is, the spec only defines an interface, and the implementation is up to you, so it's absolutely possible to implement a timing provider which runs a local server and then listens to link messages, sends link messages, and relays those as messages which the timing object can understand in the browser. And then you can, again, use the time from the timing object to control the WebAudio API, for example. And last but not least, I wanted to mention video synchronization, and this is the only case that I could think of where synchronization is actually not that, well, it's still important, but it's not that, it doesn't have to be that precise, because I think you have, depending on who you're asking, about 15 milliseconds delay that people would tolerate if you have someone talking and the audio to it. But you can get very, very precise by, as I said before, by re-implementing the video element with web codecs and the off-screen canvas, and you can get way below these 15 milliseconds. Like you can make it, perfectly accurate, because you know the output time of the audio booklet, and then you also know the time at which you put the frame on the screen, and you can make this even more accurate than the real media element. In case you want to know more about synchronization and the WebAudio API, there was actually a talk last year on synchronizing clocks, but it was more tailored towards native development, and it was by Fabian Rengils, and I recommend watching it if you haven't already. And there was also a talk from Ben Moss and Hongjon Choi on creating music on the web, and that was basically about using the WebAudio API with the audio worklet and all that that goes into it. And I also recommend watching that if you haven't. And if you want to watch the slides again, you can find them here. And if you want to contact me, that's my website. I'm also on the WebAudio Slack, on the Audio Programmer Discord, on the Discord of that conference, and anywhere on the internet where you might think you would find me. Thanks a lot for your attention.
Question: Is it is a precise timer achievable right now in Chrome and Firefox? Because all of this is not solvable if a regular user in his browser cannot get without going to like preferences tab or config about and changing that he wants a precise performance counter. That's what I faced, that I cannot synchronize them because the clocks specially were made imprecise.
Okay, the question was if the precision...
If there is a way to get with a regular user browser right now, precise clock to synchronize everything else.
Yeah, I think that's absolutely possible. Like if you enable those headers,
these headers,
then you get the shared array buffer, and it's also in Safari. Like Safari was the last, and Chrome and Firefox already had it, and that enables shared array buffer, but it also removes the smoothing of the timers at the same time.
Thank you.
I had a follow-up about that. Under what circumstances can you not declare the content safe? And under what circumstances can you declare the content safe so that those headers will give you that?
I read it 2 times when I had to implement it, and I forgot it right away when I was done with it, because it's very complicated. It's like, if you know the cross-origin resource policy headers, it's basically a very aggressive version of that. Like it's saying only, like if you do web development and you have a website and you request something from, let's say, Google, on your page you have an image which you don't host yourself, you got it from Google, then that's fine. You can just do it, and it works. And you can't do it if you require JavaScript from Google. There's a difference because for historical reasons, people thought JavaScript is more dangerous than images, and then the resource which serves the JavaScript has to explicitly set a header. It's okay for this to be embedded by anyone or to be embedded by a specific website. And these 2 headers basically say that has to be done for every resource, even for images, and cannot be, you cannot avoid it. And that breaks a lot of things, like if you have a lot of third-party content, and because no one was expecting that so far. But if you're lucky and you don't have, then I would recommend doing it.
Great, thank you. Any other questions?
All right.
This timing provider class, will it work right now because I'm just unfamiliar, or it's just planned for future? Like, will it work in an unmodified regular browser?
Yeah. Well, it's a specification which is a draft forever. Like, it did not progress because no browser vendor wanted to implement it. But that's not a problem anymore because now it's possible to implement it yourself. Like, the low-level APIs are there to implement it yourself.
And does it use internally precise clock somehow?
Yeah, well, it uses what it has. Like, if you set the headers, then it will use. Like, the API is absolutely the same. Like, if you set the headers, then performance.now will be performance.now, but it will just return you a more precise value. But yeah, does it make sense?
Yeah. It's bad, but
and and in terms of all these different fragmented APIs that you've talked about, is there hope that they will rationalize in the future?
I don't know. I think there will be even more. Like, Apple proposed actually another high-level API called Media Coordinator, which is again going against the principles of the low-level of the Extensible Web Manifesto. But Apple also has a lot of power to push things. So yeah, it really depends on. It's not always the best API that wins. It's sometimes also the API which is already there. Like, sometimes there's the argument like, it's already there, now we need to have a spec for it. So that's also happening. Yeah, it's chaotic. But it's open. Like, the W3C, like, you have to be a member, like, to have actually the power to vote. But all of these APIs are developed on GitHub, and you can file issues, you can complain, or if you have any ideas, also you can post them there.
Hello. Hello, Chris. Maybe you should clarify something, is that it is possible to play perfectly in sync, multi-track songs or whatever, but not streamed content. You focused on that, because if you are loading samples in memory and decompress them, and if you are running this, you can write very easily a multi-track player, for example, that plays all the tracks in sync. And if you want to have sample accuracy and not block accuracy, you can also, if you are writing this in an audio worklet. So this is possible, but I think you focused on stream media.
Well, at least I try to say that you can do it if you do have an audio buffer source node and you load the buffer yourself, then you are safe and you can do what.
Yeah, because it was a bit, you gave a view of the landscape that was a bit frightening. So, of course, the media recorder, for example, API, is not done for computer music. It's done for, let me record what I'm saying in the microphone and post it on the blog or whatever. Or use it with WebRTC for video conferencing and things like that. It's not for sample accuracy and computer music, but web audio is made for that. And the thing that you have to load in memory and decompress everything is also constraining. So web codecs that he talked about is also an API that you will be able directly in the browser to decompress a part of a long audio file, for example, work on it, like in a DAW, and when you move forward, then it will decompress on the fly and so on. So things are evolving. So I'm trying to be a bit positive.
Sorry, I didn't want to be this pessimistic at all. Like Michelle and I worked with this for a long time, and we're still alive and we still like it. So that wasn't meant to be pessimistic at all. I just wanted to give an overview of all the things that people could do, and I see a lot of people actually doing this on Stack Overflow and then complaining about why this doesn't work. So I wanted to explain why.
Hi, thank you for presentation. And as when we develop for web, we are also developing for mobile. And have you ever experienced any problems with sync in mobile version of Chrome, Firefox?
Yeah, the mobile story is that's actually a very sad one. And that's because I think I have to say this explicitly, Apple is blocking modern browsers on its devices. Like every browser on iOS is Safari, and it's not even the real Safari, it's mobile Safari, which has features. And these features basically disable certain things, and it's tricky, but there are always ways to, like in web development, there's this the concept of progressive enhancement, and one thing that is absolutely doable every time is that you detect where you are running, and if you can do something, then you do it, and if you can't, then you tell the user, sorry. It's even better to not tell the user, but to tell them, but to also provide a fallback strategy. Like maybe if you want to play something in sync and it doesn't work in Safari, you just play one of the tracks at the time and say, yeah, sorry, it doesn't work.
Thank you.
Okay, dashing over to this side.
Hi, Chris. Going back to that slide where you were talking about synchronizing video back with audio that's been put through the web audio API. Yeah, that one. Could you just talk through that a little bit, like how you would actually go about that? So let's say if we were to apply let's say noise reduction to an audio signal and we were to get the user's webcam, how do we then join those back together if we know what the delay is on the audio?
Well, yeah, the idea is that you don't use the high-level APIs, and instead you would go low-level and do you have the chance to, if you get the input stream from the camera, you have the chance to get the actual samples and the actual frames yourself. And then you would basically store the samples somewhere, the video frames somewhere, and somehow keep track of which samples they belong to. And then you would pipe this through the Web Audio API and would kind of map it back together. Like you would have to delay the video by the same amount as you would need to process the samples. it's tricky, definitely. Like, it's not trivial, but it can be done. As Michel said, it's not impossible, but yeah. Does that help already, or should I?
Yeah, I think I just need to play around with it and experiment. But it's
Yeah,
the passing the data across potentially. You know, do we use worklets or is this all?
Yeah, web codecs is one of those newer APIs which are available on the worker by default. Like, you can do this on a worker, and that it's also a possibility to know that you're not interfere with the main thread, and yeah, you get better performance there. But the old APIs, which weren't primarily meant to be on the worker at first, it takes a long time until they finally come to the worker.
Only if you know, will iframe help to get precise clocks?
Well, I'm not sure if I understand the question. If an iframe
Load a separate page in iframe, get clocks there, and get things done synchronized there, like a flooding.
That's actually a very mad way of doing it, but it works. Yeah, there's.
It works. Okay, thank you.
It doesn't work in every case, but also that's also a side effect from the mitigation of the Spectre meltdown attacks, that certain websites do not share any processes anymore. And the very easiest way to make this happen is if you serve content from 2 different domains, and they will be isolated by default. And that way you can kind of sheet and get a clean instance for you, which doesn't use all the heavy React main code or something. And then, yeah, you can do it there. Yeah.
Okay, thank you.
Any other questions? Okay, if everybody would like to thank Christoph, give him a hand.
Thanks again.